Good day. This is a grade 12 notation video. Somebody sent me this problem and I just decided to make this video. What we're going to do is we're going to explain what all these notations here mean. All these ways of writing, each thing means something. And I'm going to do it using this function, the sine 2x function, y equals to sine 2x function. I'm going to use this graph and explain all these notations. Remember that if you have a specific problem now in grade 12, with a specific question, you can send a WhatsApp picture of your problem to this number, and I'll look at it and see if we can analyze it and make a small video for you to explain it. Enjoy the video. What we're going to do, we're going to work with this function. The function is called f of x equals to sine 2x, which is this red snake walking here. And then the next one, they put a restriction on here. X lies between minus 180 and 90, starting at minus 180, going up to 90 degrees, including both of them. And then here is your y-axis and your x-axis in blue. I also put in all the critical coordinates everywhere that we will need in our discussion. Please stop the video and just get the feeling on this graph before we go on. I made quite a few videos on notation starting in grade 10. This is like at the end of the notation system. In this, as we look at this screen now, there's already a notation here, something that's written here. There's interval notation over here. There's actually a graph on a number line here. So there's a lot of notation before we start with this complicated stuff we're going to do now. From here on, I will indicate the stuff we're talking about in colors. So here's our first situation. They say f of x equals to 0. So they're asking us, where is this graph equal to 0? This 0 means where y is 0. That's on this red line. So our answers we will find where f of x equals to 0. That's on the purple dots. So it's where the graph is on the x-axis. And then these are the answers. Minus 180, minus 90, 0, and 90 is the answers in this way of writing. The next question asks, for which x values is f of x bigger than 0? F of x is the red snake, and 0 is that blue line. So where is the red snake? Bigger than 0, which means above the line. That's there and there. We can also say it's where the graph is above the x-axis. We can also say where the graph is positive but not equal to 0. Then this is the answers we'll find. Is this red part that I colored in here, where the circles mean excluding those two parts. Please stop the video and look at this answer. The next one we use is f of x is smaller than 0. It means where the graph is under the x-axis, where this red snake is under the blue line. That is where the graph is negative and not equal to 0. It is only the red part that I colored in there. So it's x is bigger than minus 90 and smaller than 0. Please stop the video and see how it works. This writing means they want where the graph is bigger and equal to 0. So that's where the graph is above and on the x-axis. Where's the red snake? On the blue line and above the blue line. So that is where the graph is positive and equal to 0. So the answer lies on those two red places. So it's x is between minus 180 and minus 90 included, and also between 0 degrees and 90 degrees included. Please stop the video again and look at the answer. Please stop the video and get your brain around what we wrote here. The rest of the video you won't understand if you haven't done calculus in grade 12. So if you're looking at the video before you did calculus, stop the video and stop looking from here, please. If you have done calculus, you would have run into the first derivative, this way of writing, f accent of x. This refers to the gradient of the graph. What I also did is I again restricted the domain further. So we're only going to use the part of the graph that runs from minus 90 up to x is 90, including both of them, for the answers we're going to do now. So now we're going to work with the gradient of the graph, and we have to explain gradient. Here the gradient is negative, here the gradient is positive, here the gradient is negative. The gradient at the turning point is 0, the gradient at the turning point is 0. We read a graph from left to right, so you move always like you read a book from left to right. As you move, if you go down, it means it's decreasing. If you go up, it's increasing. If you go down, it's decreasing. So here is the first notation you will see. It's asking us, where is the gradient bigger than 0? I wrote it in for us. It is where the slope is increasing, or positive, some people call it, looking from left to right on the graph. So the answer is this red piece of the graph. In other words, it's x is an element of from minus 45 degrees up to 45 degrees, excluding them. Stop the video and look at it, please. The next writing you will see is this. So they're asking, where is the gradient smaller than 0? Which means the slope is decreasing or negative. Looking from left to right. As x increases, our final answer will then be where you see the red lines. So the graph is decreasing there and there. So the gradient is negative on those two parts. The minus 90 and the 90 is included with a square bracket here because the graph is on its way down still when it hits him, and it will be on its way down when it hits that guy. It's excluding the minus 45 and excluding the 45 because at the turning point the gradient is 0 and not positive or negative. The last one on gradient that we are doing is where the gradient is equal to 0. So that's where your gradient is equal to 0. Is that what that writing means? It's at the turning points, or called the stationary points, and the answer is only x, an element of curly brackets, two possible x values at minus 45 and at 45. The two red dots that you see on the graph. Please stop the video and get your brain around this notation where we use gradient. That was the first derivative, is the gradient. The last notation we're going to do on graphs is the second derivative and how he influences our information on the graph. I wrote here, f double accent x refers to the point of inflection. I changed our domain back again just to force you to do it in your brain too. We're working again from minus 180 up to 90. You should remember from calculus that if you take your second derivative and you equate it to 0, you find your points of inflection. That's the purple dots you see on this graph, where the graph changes from concave down to concave up, again to concave down. It's where the red and blue meets, and the blue and the red meets, and again at that point there. Also remember, if the graph had to go on, here it will be changed from concave down to concave up, and on this side from concave down to concave up again. That's why the purple dots are my points of inflection, and that is where my second derivative is equal to 0. So this is my answers. Loose x values, minus 180, minus 90, 0, and 90. That is the answer to this question. Where is the second derivative equal to 0? The next writing looks like this. It says your second derivative is bigger than 0, which means is where the second derivative is positive. This some people might not understand, but you must just then believe me. It's this answer. X is from minus 90 up to 0, the red part here. So if your second derivative is positive, everywhere where it's positive, your graph is concave up, excluding the points of inflection because there your derivative is equal to 0. So this is the answer if they say second derivative bigger than 0. It means it's the part where the graph is concave up. Next we have to find the part where the second derivative is smaller than 0. Smaller than 0 means negative, so where your second derivative is negative, that's these two red parts, and that is from minus 180 excluding, up until minus 90 excluding 0 all the way up to excluding 90. Please stop the video and get your brain around all these notations on the second derivative and what it means. This is most probably the most difficult part of the notations we did on this video, because it's only explained briefly in class. Look through this video once or twice and get a feeling on how this works. Please indicate whether you liked or disliked the video, and subscribe to the channel if you want to. If, like I said in the beginning of the video, if there's something you're not sure about, send a WhatsApp picture to this number. We will analyze your problem and see if we can find a solution for you and put a video out to explain it.